Excuse me? Yes? Wow, very captivating. Is it Carnatic music? I wish I had the chance to learn it.
Wow, you're interested in Carnatic music? Come here, I have an app to show you. Yes, so this is Swarakrita, an app exclusively for Carnatic music. Do you want to give it a try?
Yeah, sure, definitely.
Okay, so let's move into musical connections. Can you make out something from these four pictures?
Uh, those are pearls?
Yes, that's great. So this would go to Muthuswami Dikshitar.
Hmm.
And in case you couldn't make out what the previous question's answer was, we have the reasoning button as well. So learning is the main thing in this. And similarly, there are many questions and a scorecard exclusively for you as well.
Wow, that is awesome. I can learn as well as play. That's just great.
Yes. So do you want to try another game?
Yeah, sure.
So try to find out the raga.
I don't know.
Okay, I'll help you out with this. So this is in a raga called Sama. And in order to help people who are just new to Carnatic music, we have the info button as well. We have an option to view the lyrics of our favorite song. And now, since you told me that you're not much familiar with Carnatic music, we have four filters from which you can find out any song's lyrics. What language are you familiar with?
Tamil?
So here goes. You have a famous composition, lyrics in Tamil. Isn't that cool?
That's just awesome.
Now, we'll explore another feature which is pitch detection. Ready? Now, I'm gonna use this app to find out what pitch I'm singing in. Sa pa sa pa. Wow, that was super quick.
To be talking about how we are going to do the sound classification, which is basically the classification for predicting what a raga the user is going to be singing in, which is made as especially for classical music. For now, we have also included Hindustani as well as Carnatic music in the data set. So I'll be using the Librosa module to load the music, and the music is all saved in the WAV form, and this is a rough plot showing the music. With this Librosa module, we can plot whatever musical audio that we want. And there is an interesting feature called as MFCCS, which can be calculated again by using the Librosa module, which gives a rough summary of the frequency distribution across the entire audio file. So with that, various predictions about the music and the analyzing the music in general can be made. Both its frequency as well as its characteristics can be easily analyzed with this summary. And this is the extract features function, and I have given the file path for the directory, and roughly this is how the data will look like. That is with the MFCC features. Then I am importing the TensorFlow and I am adding many number of layers, many dense layers and activation layers. I'm using activation layer Relu to find similarity patterns. These all come under the hidden layer, and as you can see, we are using the sequential model over here because it's going to be the simplest. And finally, we are using the softmax function activation layer to get a smooth output, and I'm doing multiple epoches over here to train the model. Finally, after the model has been trained, I'm passing the entire test dataset inside the model. In case I'm passing one particular file, for example, from over here, I'm passing a file from the Bhairavi raga. The model is actually correctly predicting that it falls under this category. Is the path. I've given Bhairavi1.wap as the input and it predicts it to be Bhairavi, and Asavari. So it first converts the audio that we give into a two-dimensional array of MFCC scaled features. Based on the scaled features, it is going to predict what particular raga it is going to be. Similar to this, like predicting the raga, we can also predict the note that the particular user is singing in and also the pitch that they are hitting. That is what we are trying to achieve with our app.